These beginning notes are just going to take you through the different terminology and critical points of a polynomial function. Some of these you have seen before, and some will be a little new, but most of the stuff you've seen before with the quadratics and other functions in the functions unit, we're just going to kind of go back and just go over them for polynomials. So zeros, or x-intercepts, are just where the graph crosses the x-axis. In this graph, we have 3 of them, so I'm going to label these in different colors here. I'm going to do these in gray. Hopefully you can see them. And I'm just going to label that 1, 2, and 3. So in the example, point 1 is about -2, 0. 2 is about 1, 0, and 3 is 3, 0. So those are your zeros of your graph. Then we have your y-intercept point. The y-intercept is just going to be where the graph crosses the y-axis. These are things you know already. And that point is going to be, do that one in yellow. That's going to, I'm going to call that number 4. And that's the point 0, 1, 2, 3, 4, 5, 6, 0, -6. Now on this graph we don't have them, but when we look at the example together, later on we'll talk about actual maximum and minimum points. You have the highest for maximum point on the graph, and you saw this with the quadratics. That's where your vertex point was, or minimum was your lowest point on the graph. This graph does not have either. This graph has what's called a relative maximum and a relative minimum, and these are just turning points on the graph where it changes from increasing to decreasing or decreasing to increasing. So a maximum is a turning point. And I would underline that because it's not an actual maximum minimum point, but it kind of looks like it if you ignore the arrows, where the graph changes from increasing to decreasing. In this example, we have a maximum point right here. So that's, I'm going to call that number 5. When we do these later on, we probably will label them in order so that this doesn't get confusing. But point number 5 is about 2, 4, and that's a maximum, a relative maximum. If you notice, we still have this arrow going up here, which is higher than it, and that's why it's not an actual maximum point, it's a relative maximum. And then a relative minimum is just the opposite. It's a turning point where the graph changes from decreasing to increasing. So that helps you with the next step down below, identifying the increasing, decreasing. And on this graph, I'm going to label this one in blue, number 6. That point is about -1, -8. Now you would use points 5 and 6 to help you determine where the graph is increasing or decreasing. I'm going to use inequality notation here. I would like you to try to put it over into interval notation. You can check the hard copy of the notes that are posted also for this. So if you look at the x values from -1 to 2, that's where it's increasing because that's where we have that maximum point. Now I'm going to draw over this in green. This is where the graph is increasing between those 2 points. And then the other 2 spots that are left in black are where it's decreasing. So it's increasing from -1 to 2. Remember, you just do less than signs. And then it's decreasing. I'm not going to do colors for this one, but it's decreasing from -infinity to -1. Or 2 to infinity. Because there's 2 spots where that's happening. Again, you're using points 5 and 6 and the x values from those to determine your increasing, decreasing for your graph. Now we're going to look at the range and then when the function is greater than 0 and less than 0 on the next page so that I can mark up the graph a little bit differently in terms of colors. So you're just going to have to kind of follow along with that information. Okay, so here is your, I'm going to put in orange the 0 line. Now our range is going from -infinity to infinity because we have arrows pointing up and down. I cut off the arrow on the other spot there. We're going to use the zeros as a reference point for these. And again, use the x values because the zeros have 0 as your y value. So these 3 points are what we're using in terms of coming up with that information. And then I'm just going to put in red where it's greater than 0. And then in blue where it's less than 0. And that's going to help us determine those things. So the function is greater than 0 from -infinity to -2. So that's your first x-intercept. Then it's less than 0 after that until you get to 1. And then from 1 to 3 it's greater. So 1 is less than x is less than 3. So I just identified the 2 domains for the red pieces. And then it's under the x-axis, or less than 0, from -2 to 1, or from 3 to infinity. Again, identifying the 2 colors that I put on the graph there. Now I know this video is a little longer than my normal ones. We're going to do one more piece for this. If you need to pause it, take a break, or go back to anything and recopy it, definitely do that. The last part is just talking about the turning points and how we're going to come up with that information and use that for future graphs. The graph of every polynomial function of degree n has at most n minus 1 turning points. So if it's a degree 3, it would have 2 turning points, possibly. It doesn't have to have that many, but it has at most that. The key with this is if it has that many zeros, so if it has a cubic function has 3 zeros, then it's definitely going to have exactly n minus 1 turning points. So if you look above at the one we just did, that could be an example of a cubic function. It has 3 zeros and then only 2 turning points, so 1 less than the degree measure. Now that you have these notes filled in, we're going to use this information and your graphing calculator to do specific equations and find this information from graphs.